In this video, we're actually going to be showing you how to solve an equation that has two radicals in it. Solving an equation with one radical is pretty simple, but when you have two radicals, it's way more complex. So the first thing that most teachers will tell you to do is to isolate, or get by itself, the radical that is more complex. Now, by more complex, they mean which one has more stuff underneath the radical. So technically 2x plus 3, they're calling more complex than the x plus 2. So what we're going to do is we're going to isolate the 2x plus 3 term, the radical. So to do that, we have to add this other radical to both sides. So we're going to add the square root of x plus 2 to both sides. So plus the square root of x plus 2. Now we're just going to rewrite that. So what we have is the square root of 2x plus 3 is equal to the square root of x plus 2, and then plus that other 2 that's up here. So plus 2. Okay, now the next thing we need to do is we have to figure out a way to get rid of this radical. Now radicals have what are called indexes. The square root, the index is 2. You never write it, but it is there. You know, cube root will be to the have an index of 3. To get rid of a radical, you raise the radical to the index. So if it's the square root, to get rid of it, you're going to square it. If it's the cube root, to get rid of it, you're going to cube it. If it's the fourth root, to get rid of it, you would raise it to the fourth power. So let me just make sure you understand that. If we have the square root of x, that's the same thing as x to the 1/2 power. Okay? Now, if I were to take the square root of x and square it, what I'm really doing is taking x to the 1/2 and then squaring that. Well, when you take a power to a power, you multiply their exponents, so you're left with x. So if I square this, okay, I'm going to be left with just what's left under the radical. So let me rewrite that to show you. I'm going to square this side, and then I'm going to square the right-hand side. Squaring the right-hand side is way more complicated because of that extra plus 2 on the outside. Okay, so the left-hand side is just going to be what's under the radical, so 2x plus 3. And the right-hand side, hopefully you understand that this is a binomial, 2 terms times a binomial, so we're actually going to have to FOIL. So I'm going to write it out longwise for you, or, you know, expanded, so that you can see that. So times the square root of x plus 2 plus 2. Okay, so the left-hand side stays as 2x plus 3. And now we're going to FOIL. So FOIL stands for first, outer, inner, last. F-O-I-L. So first, the radical times the radical. Again, that's the same thing as we did up here. It's the same thing as the radical squared, so you're going to end up with whatever's underneath the radical. Outer, 2 times this radical is just going to give you 2 times the radical. Again, inner, same thing. 2 times the radical. And then last, 2 times 2. Sorry. So 2 times 2 gives you 4. Next thing to do, add your like terms, or combine your like terms. So 2x plus 3 on the left. On the right, we've got some like terms. There's nothing that adds with the x, so we're going to leave it as x. This 2 right here and this 4 combine to give us 6. And then 2 square roots of x plus 2 and 2 square roots of x plus 2. This is the same thing as like adding 2x and 2x. You get 4x. So here we would get 4 square roots of x plus 2. Okay? Now what we need to do is, in any problem, you want to isolate the radical again, because we're going to need to square both sides one more time. So let's get these two things to the left-hand side. So we're going to subtract x, and we're going to subtract 6. And what you end up with is, on this side you end up with x minus 3, and on the right you end up with the radical. So what we end up with is actually x minus 3 is equal to 4 times the square root of x plus 6. I'm sorry, x plus 2. Just go back and make sure that's right. Yeah, x minus 3 equals 4 square roots of x plus 2. So the next thing we're going to do is, to get rid of this radical, we're going to go ahead and multiply, or, you know, raise both sides to the second power. So square both sides. Square this side. Square this side. Again, we got a FOIL. So x minus 3. If you get FOIL in your head, you don't need to write this out, but it's a little bit easier to see it if you're not real good at foiling. This side is going to be this times itself. So 4 times 4 gives me 16. The square root of x plus 2 times the square root of x plus 2 is x plus 2. You can think of, the exponent and the radical canceling out if you want, but just make sure you realize that you also have to take this to the second power, the 4. So that's where we get 16 x plus 2. So let's FOIL again. X times x, x squared. Outer, minus 3x. Inner, minus 3x. Last, plus 9. On the right side, you just distribute. So that's 16x plus 32. We have a quadratic so far, so what we need to do is set it equal to 0. So let's mess with the left side first. We've got these two like terms right here, so we have x squared minus 6x plus 9 equals 16x plus 32. And like I said, it's a quadratic, so we need to set it equal to 0. So minus 16x minus 32 minus 16x minus 32. So what we have is x squared minus 22x minus 23. So let's go to the next page and rewrite that. X squared minus 22x minus 23. Should make sure that was a minus. Yeah. Okay. Is equal to 0. And then we just factor. So what we need are, this is pretty easy, since 23 is prime, factors of 23 that subtract to 22. So x, 23, and 1, only choices. This is negative, so we need two different signs. The middle term's negative, that means our bigger number is negative, our smaller number is positive. Zero product property tells us that the two answers are x equals 23 and x equals negative 1. Now finally, since this is a radical equation, you actually need to go and check that both of your answers work, because anytime you have a radical equation, anytime you square something, you might be introducing what's called an extraneous solution. So we need to memorize this 23 and this negative 1, and then go back and look at our original equation, which is right here. Let's see if we can just copy this. We got 23 and negative 1 as our answers. Okay, so let's try to see if they both work, if one works. See how this goes. So we're just going to go ahead and check x equals 23 first. So we're going to take the square root of 2 times 23 plus 3 minus the square root of 23 plus 2. We're going to ask ourselves, is that equal to 2? So we've got the square root of 2 times 23 is 46 plus 3 is 49. Minus the square root of 25. You can pretty much see what's going to happen here. Is that equal to 2? So we get 7 minus 5. Again, mathematically, you should be writing it like this, but you can see what's going to happen. And we get 2 equals 2. Since that's a true statement, we know that x equals 23 does work. This is a true statement. Okay. Now the second thing we're going to do is we're going to check to see if negative 1 works. So we're going to plug negative 1 in because that was our other answer. So we have the square root of 2 times negative 1 plus 3 minus negative 1 plus 2 underneath the square root. Is that equal to 2? So this is negative 2 plus 3 is 1. So we have the square root of 1 minus the square root of 1. Is that equal to 2? Well, we get 0 here, right? We get 1 minus 1. Is that equal to 2? We get 0 is not equal to 2. So we know that x equals negative 1 is not a solution. So that means we only have one solution to this whole thing. This crazy problem that we started out with at the very beginning, the only answer is x equals 23.